Introduction, and thank you very much for having me here. I'll just shut down the video. As said, my name is Shani. I've been with Autodesk for many years, and I work mainly with the latest and most advanced technologies that we deal with, meaning 3D for the most part. And I work closely with most of our advanced and strategic accounts, mainly in the Western Hemisphere, but lately in the Eastern Hemisphere and in the production countries as well. So today we're going to be talking a little bit, and we'll try to do it fast. We have about 30 minutes. About the virtualization in the textile world. And when we say virtualization, it's basically taking something that was done for real in real life and virtualizing it in a computer using computer graphics. So the initial motivation for us, and as said, we started developing the 3D more than 10 years ago, early 2000s, and the initial motivation was simply to give the pattern maker some tools for him to see what is working on in terms of flat patterns in the standard PDS environment, just to improve his productivity and to improve the skills of the pattern maker. It wasn't, we've never tried to replace the pattern maker or to bring something that will replace the professional pattern maker, just additional helpful tools for the pattern maker in order to bring him his skills to his full potential. So that was the initial motivation, and from there you'll see where we've added with these features. And originally it was what we call a natural extension of the 2D CAD. So it was simply another module within the PDS environment, the pattern design system environment. Just another place where you can open another window and visualize what you do in 2D, just do it in 3D. Apparently what happened is that this small module or this extension became something that is revolutionized the work process in the textile industry. And instead of doing standard step of evaluating of evolution and progressing, just like we had with mobile phones, so you had a faster phone, a better phone, a smaller, and at a point of time, someone came with a new idea and revolutionized the mobile industry, and everyone are carrying now, touchscreen phones and much more advanced. So the same thing that we see with other industries is now happening in the 3D environment within the textile industry, where you can suddenly work in a totally different environment, doing stuff that you weren't even able to dream about before that technology came by. So but we must be thankful for hardware suppliers that simply made this those laptops that we see here, or even those mobile phones available for us at feasible prices. Mainly because of kids playing computer games. And so the video card industry and the CPUs industry became affordable, and everyone now can purchase it for their home or office usage. And we simply take those tools and harness them for the textile industry usages. So some of the technology enablement that brought us to where we stand today. If we look back to the 60s, for instance, the car industry, we're now in the textile business, but many years ago, other industries computerized themselves and virtualized their entire production supply chain and pipelines, totally CAD-oriented, totally 3D-oriented. And one of those industries, and we see here some names from Renault and Citroën, Bizier is one of the most famous engineers at Bizier, who did a lot of work for the computer computer graphic industries. So here's an example. It's a video from YouTube that you can download from Ferrari website. Basically, it shows the textile portion as part of the car industry, where we had the same transformation, starting from manual labor, working with older material types, and going through all this transition, eventually doing everything digitally on a computer screen, as you can see here. Robotics, advanced technology, using new materials such as carbon fibers. All of that became available simply because they took advantages of the latest technology, the latest academical researches. As you can see here, it's all related eventually to producing textile or textile goods or car seats, but it uses the latest and greatest technology available on Earth. And we believe that this technology should be available for the textile market overall, here as well, and in any other places in the world. So I'll just stop this movie here and go to the 80s, where we've seen many CAD providers around the 80s evolving from small companies to very big ones, who enabled the aerospace and the car industry to and the standard architecture industries to grow. And again, we believe we can bring the same message to the textile industry. And one of the partners that we work with that started in the 80s but now work closely with us on some project is Autodesk. And again, this is a YouTube video, and it simply shows what is done today, and also you can see the cloth simulation there. In the car industry, in the architecture industry, everything is done on a computer, computer simulations, animation, obviously, using the latest tablets and cell phones. And we, again, would like to bring the same conceptual to the textile industry. And obviously, if you build a house now or a building or a city, nobody will use paper patterns to do that. And 50 years ago, they did. So that's something that we're trying to change here in this industry as well. One last industry that we have to be thankful for allowing us to bring this exciting technology into the textile industry is the entertainment market. And they've done a lot of work since the early 2000s on simulating computer-generated cloth and fur. And I'll just stop it here. But this funny T-shirt that you see here, and the movie was released in 2001. They started working on it in the late 90s. But that was one of the major challenges in this Monster Inc. movie, was to simulate this red T-shirt. And a lot of the work that we've done later was built upon their research for achieving the challenge of a simple computer-generated film. Another project that's worth mention is the what's called Final Fantasy. This is considered to be the first ever made movie that was done fully with computer-generated and photorealistic figures. The cloth that you see here, I'll just stop it here maybe. The cloth that you see on the figures were actually developed by a company who later became Cyflex. The name of the company was Cyflex, and they did a cooperation with PAD, the textile CAD company, trying to bring in 3D to the textile industry as well. And one last movie from the entertainment is this is the Brave. It's from this year, and the same Pixar team that did the Monster Inc. actually also did the cloth simulation here on the Brave, and as you can see, the cloth become much more complex, quilting and knots and multiple layer garments, and that's basically what we're also bringing to the textile industry. If we could 10 years ago simulate very small and basic T-shirts, now we can do very sophisticated garment with multiple layers and complex components. So it just shows you one progress in one industry and the progress that we have in another industry. Some industry leaders that we work very closely with from the footwear industry, for instance, and Adidas is one of our largest accounts in the world. And try and open it. What they were able to simply virtualize almost all their production cycles, and they produce everything in 3D before they even try to do something for real. And that goes for shoes, for accessories and gear, for bags, and for apparel, as you will see, gloves, shields, and apparel. So let's go back. And one last movie, again from an industry leader in the car industry, where, as you will see here, with latest technology, you can simply customize your car. In this case, it's a Ferrari, but you can simply customize everything online or in the store before anything was made for real. So you can customize the colors of the cars, the interiors, the car seats, the leather. Everything is fully customizable. Everything that you see here is computer generated, obviously. No such car was ever made up until you purchase you push the purchase order button, and again, this is the direction that we're bringing to the textile industry as well. And eventually, someone needs to cut and sew the real car. It doesn't stay in the computer, but that's the part that we want to get into. So, integrating new workflows in CAD technology to empower Indian vendors' natural advantage. So, using our technology, where we want to help you, the vendors, to keep your respectable prices, to be competitive with other vendors around the globe, to enrich the spectrum of offering that you currently have using our technologies and using technologies such as ours, to be more creative, to be able to create more samples, to offer more products to your vendors in the virtual world, before even considering to do anything with it, to simply be more creative. Everything can be done today on the computer, so you're not limited. You can be more flexible. You can respond faster to their requirement, and obviously keep the respectfulness and patience towards the changing demand of the market, and being a team player. So some of our customers, and those are the ones that I personally deal with mostly. From the Western Hemisphere, I would say probably some of them are buyers for you. So Walmart, for instance, Kohl's, Target, Marks & Spencer, Tommy Hilfiger, Hugo Boss, Coach Leather, Chico's. Those are not just name dropping. If we want to step back a little bit, Autodesk traditionally was a small, medium, and educational-oriented company because we are Windows-based, native-based platform. So it's more intuitive and it's more easy, but in the last 5 to 6 years, since 2006, when we came with the concept of 3D, many of those giant companies simply started working with the 3D technology, first to improve their own backyard processes and block development and fit analysis and everything, but also to improve their communication with the vendors in the Far East or elsewhere on the globe. So all the names that you see here are actually companies that embrace the 3D technology at their headquarters and are now starting to populate the 3D virtualization technology into their vendors and partners worldwide. So you see also Coldwater Creek, Johnson Control. By the way, you've seen some nice car images before. Johnson Control is our largest account worldwide, and they produce car seats and interior. So how to approach various challenges of the apparel industry by using advanced 2D and 3D CAD and virtual prototyping solution. Some of the challenges that you all are facing, and you know, we hear that and we capture that from our customers and our partners in the world. So communicating globally, communication gaps due to languages, time differences, culture differences. They say that an image worth 1,000 words. So simply send an image of a 3D representation of a file and get a response without having to explain, well, I meant this shoulder, that shoulder, this pocket, the other pocket, and it simply saves a lot of communication issues while using visual representation of something that you want to talk about. Quality of product. So obviously accuracy is something that is paying for all the apparel industry, and everybody is worried about the fit and the quality. So we just want to bring the technology in order to improve this barrier and eventually reach the market with better product and fit and better fit. Improving productivity, again, cycle time reduction and efficiency, obviously saving fabric, saving samples, saving shipment cost, and shortening time to market. So now we're going to be talking a little bit about the communication tool and the challenge of communicating global. So this is a case study that Academy Sports were kind enough to share with us together with Renaissance India. So and they've done this work. We just took from their, they allowed us to take from their presentation a couple of slides in order to show the success of how simple it is to communicate using images and visual representation rather than just exchanging emails or phone calls. So those are the standard blocks and slopers that are sent to the vendors, and they can start doing the actual specification the actual specification patterns based on the spec that they receive. So here's a pattern that was developed by the buyer with the spec requirements, and then the patterns that were generated for this specific block. The measurement of the mannequin that you see here on the left hand side is actually was scanned using a body scanner, and the measurements were automatically applied over our parametric mannequin. So the accuracy of the mannequin is very important in this section as well. So some changes that you can do and instantly view them if you want to change the neck width by 1/4 of an inch or 1/2 an inch, you simply ask the operator. He will do it and instantly send you back an image of the result after this change was done, and you can say, okay, I like it better, I don't like it. Let's go back to the previous version, and nothing really happens. You don't lose time, you don't lose money, you don't ship anything during that session. It's all done in the virtual environment. Again, doing some correction on the front neck drop, which is something that sometimes it's difficult to find exactly where my problem is, whether it's in the lower part of the neck pattern, in the upper part of the front pattern. So this is something that really helps you communicate better with your buyer and help them understand the challenges of the pattern making and of the fit, and help the buyer understand your challenges of building those pattern and blocks. And obviously it can eliminate all the size analysis that you do for various grading. So if you say, I want to create a real sample only for size medium, but I don't want to test a real sample of size large and extra large, and I can do them virtually now. So this is another big advantages of the system. Quality of product and accuracy. We go now to the solution. So the physical simulation or the virtual garment is made out of three major inputs. One is the flat patterns. Okay, obviously you need flat patterns in order to generate 3D representation of a garment, just like in real life. The other important factor is the model dimension or the mannequin dimension. So as we explained, we can take it from body scanners, we can take it manually, we can simply enter those numbers. And the last one is the fabric properties, the physical characteristic of a fabric, whether it's the bending, the stretch, the shear analysis. Those are all important factors. So the way we handle them is that we have more than 90 body morphs that control the body measurements of our mannequins. Obviously, we have men, women, children, and all. And eventually, you reach your exact fit model representation in the virtual environment. You can actually bring in the Alvanon form directly into the OptiText environment. So if you're using Alvanon, you can bring their form directly into OptiText. As mentioned, we support multiple genders, ethnicities, and age range. So that's the way you generate the model. If you have a good model, you can start worrying about the physical simulation. The next stage is to bring in the fabric characteristic, because if I'm simulating cotton or silk or leather, I would expect a different drape result. And nobody knows what is the stretch resistance of polyester, 95% cotton and 5% polyester. Nobody knows that. So the way we've handled that is we came up with a simple, what we call fabric testing unit, which allows you to put the swatches into this machine, and the machine automatically connects using a USB port to the computer, generate the relevant fabric characteristic, including bending, stretch, shear, friction, thickness, all those important factors that are important for a cloth solver to generate the physical simulation. And then we can ask the computer to simply simulate those sets of pattern with those fabric characteristic under the mannequin that we use as a draping target. And we can even get tension indicators to know where we have fit issues, whether it's too tight or too loose in some areas. The next stage is once you have, let's go back. Once you have a physical representation or a geometrical representation of a cloth or of a garment, and you're happy with the fit and you're happy with the drape, the next stage is to do the visual representation of it, which is simulating the appearance, or what we call the light reflection and the light observant and refraction of from the fabric and from the material itself, the way it appears. So those are some snapshots from our software where you can simply press a button. We call it Beautify Path, and it takes the plane geometry and applies textures on it, colors, other materials, and generate this level of photorealism, where we anticipate that within the next couple of years, just like they currently do in the entertainment industry, we'll be able to generate images that it will be very difficult to tell the difference between real images and computer-generated ones. So we're getting closer. but we're still not there. One of the challenges that we were facing trying to solve cloth, and you've seen even Pixar were struggling with that, and this is a project that we've done with WetFX. It's a New Zealand-based company that did the movies Avatar and Lord of the Rings, and it shows you how complex a simple piece of garment can be, just because it can have so many multiple self-intersection where the cloth collides with itself. So our engine, our algorithm, had to solve all those problems. And here are some example of virtual versus real, and obviously those are marketing images that were taken, and this was simply a snapshot taken from the software, just like a real sample would have been made. Once you have a physical and an appearance of a cloth, you can put it in any background for marketing purposes, for commerce purposes. You can put a background of a store, of a beach, any environment. Obviously, the next stage is to do simple colorways and mix and match. I've done this style, and I want to see it in various color Pantones or color palettes. It's a simple, like just clicking a button and instantly you see different representations. So you can, instead of doing one sample, you can do 100 samples, and you can share them with your buyers, and they can eliminate what they don't like virtually without having to spend any time and money on just doing different colors and colorways. Improving productivity. So again, the solution is quick creation of design sample and reducing number of physical sample, as we've just seen. This is a movie that was done together with another one of our strategic accounts, Coach Leather, and this shows actually a truly transformation in the way people think. And as you can see here, I just stopped it. This is a standard Adobe Illustrator sketch or spec, as many of you are probably use. But we actually use it as a reference in order to model or to sculpt a bag in 3D from scratch. Just using the reference of a standard Adobe Illustrator spec. Once we've done that, we bring the 3D salpa, as they call it, or the 3D shape into Autodesk, and then use it in order to generate the flat patterns for production. So the designer can actually now mold or sculpture in 3D from scratch. Once you have it in Autodesk, those are the production patterns that you later send to a cutter or to a plotter. And if you want, you can even take it one more step and start and play with the mix and match and the colorways and put it in different atmospheres for marketing purposes and for in-store enhancements. So once you have a 3D representation of anything, then the sky is the limit. You can place it on the buyer website, or as you can see here inside a store, and visualize it from any angle. And this bag was never made, so that's another important factor. Some interesting academic papers that were done with our technologies, with the 3D technologies, and this was done actually by Zagreb University of Textile, and they've used our software with body scanners and with various testing equipment, and they simply their conclusion was that the solutions such as ours shortening the construction and preparation time up to 50% of the total time necessary to develop a garment model. Okay, and that was done by them without our assistance or our involvement. And there were many other academical researchers such as this one that show the same result. This was actually done by another one of our customers, Jones New York, and they did a pilot of 6 months, which is now continuing to other brands in their umbrella. And they simply took a couple of vendors from Jordan and from Egypt, and they started from around 80 days of cycle for a sample, for a virtual prototype approval. And using the 3D solution, they were able to reduce the cycle into 20-something days. So from about 80, they went down to 20, just using the virtual prototype. And those are the styles that they did with their vendors. So another challenge: efficiency, saving fabric, improving consumption. And one of the solutions that we have for that is a Topplan, which is a solution that allows you to manage the orders coming from your ERP, PLM, and other systems, and populate it into the cutting room and managing the cutting table floor. So obviously it reduces material consumption, it maximizes the marker efficiency by doing so. And it provides detailed spreading information for multiple color plies, so you can combine orders of different colors from different buyers, even with different sizes, and the system will optimize it for you and eventually bring you to the best configuration for producing all those orders together. It's important to emphasize that this solution is compatible with XML and can be embedded with PLM and ERP and integrated directly into your supply chain IT systems. Another interesting slide that I wanted to show, and I think we're still on track here, is the made-to-measure concept, where you can, with OGTC now, you can simply take a list of body measurements and instantly apply them over the 3D mannequin and over the 2D patterns. It will manipulate the patterns based on the mannequin dimensions. It can come from a scanner, but it can be manually. And from there, you can either you can analyze the fabric consumption that you need to produce that and send the price to your buyer, or you can go ahead and produce it using a single ply cutter. Okay. So I'm just concluding now. So we're talking about faster cycles to win the market, to get into the market in the right time with the right product, with a better quality, and serve the buyers better than you currently do with the same team, the same personnel, the same skill, just some additional technology that you add into the equation. We obviously connect the back of the supply chain with the front, and this opens many more options for us. And let's just conclude with this nice movie here. It will work. This is a street in Israel, in Rothschild, in Tel Aviv, and that's the way we envision textile shopping in the future. It was all done with OGTC's existing tools, obviously. Simply log into a website, select your garment, select your color, see yourself in any favorable environment, and shop online.